Good evening, everybody. Welcome to the session 5 of the 6-part series on the Business Masterclass. Thank you for all those messages that you send us after each of the sessions. We have a strong fan following for this session that we've been doing. There are a lot of people who missed it live. You can always go back to the website of Rata, www.rataindia.com. Go to the event section, just put a search called as Business Masterclass. It will show you all the earlier events and you can always catch up with it. Feel free to share it with your team. Feel free to share it with your friends. It's available for all of you to learn. And we're very fortunate that we've got some of the finest professionals from the industry who have taken time out to come and share this knowledge with us. So to the session 5 today, let's get to the session. And to start the session 5, we have Mr. Roy today here with us. Hello, Mr. Roy. Thank you so much for joining
Good
us.
evening. Thank you. Thank you so much.
Awesome. So to introduce Mr. Roy has over 3 decades of all-round experience in operations, manufacturing, new product development, and supply chain in engineering, appliances, and air conditioning industry. Industries. He's held critical and senior positions in ABB, PPL Sanyo, SEIL Aircon, and Blue Star. Extensively trained at Sanyo Japan on technology transfer, Japanese manufacturing systems and quality processes, and Rheem USA on production techniques. His areas of operations has been he's headed over multi-locational manufacturing unit as a profit center with combined turnover of over 650 crore and direct workforce of over 400 people. He's headed supply chain with which has spent over 2,500 crore with a team size of over 50 people. He's headed R&D with a team size of 150 engineers across all product groups. He has set up various greenfield projects in processes and productivity improvement, driving efficiency, cost reduction, system losses, etc., technology transfer, and new product development. These have been his core competencies, which also include sourcing and vendor management. Some of his notable accomplishments are he set up the new plant for switchgear for ABB. He set up the new room AC plant in record time for Blue Star, which had the profitability in the first year of operation which is the Himachal plant. He's turned around the Wada plant in 6 months. He has managed a lot of new product launches, room air conditioners, microwave ovens, washing machines, and vacuum cleaner. A graduate in mechanical engineering, and he's completed a course in senior management program from IIM Calcutta. Member of a few CII forums focused on logistics and supply chain, Forum for the Western region, and past member of the Himachal State CII chapter. Awesome, Mr. Roy. The stage is all yours.
Thank you.
And we've had a lot of, I've shared these feedbacks. Your last presentation was awesome. We have had a lot of people who loved listening to you. So let's continue with the same thing. Over to you.
Thank you, Ajit. Thanks for the introduction. But the last one has actually put pressure on me now because probably the expectations would be more from me. So otherwise, I was thought it's a 20-25 minute session. So I thought I was a bit more relaxed, but your last sentence put me a bit of pressure. But let's see. I hope I.
You know what, Mr. Roy, I'm glad you brought this up because at the association, we keep telling all our members, that listen, let's forget about competing with each other. This market is going to explode. We have to collaborate. And if you have to compete, you compete with yourself. Compete with yourself. Set a benchmark and improvise. So I guess that's pretty much with the ethos of our association. So over to you.
Absolutely.
Let's beat the last time's presentation.
Thank you. So good evening, all of you. I'm really happy, glad that I'm back on Friday, and it has been an exciting last 4 or 5 sessions. I'm really looking forward for this session on manufacturing engineering, especially because manufacturing engineering is very close to my heart. Actually, I really thrive on that, and that's been my competency, and actually I can talk on this subject for probably hours together. But considering today's whatever time we have, what I will do is try to give a broader picture of what manufacturing engineering is and what benefits you can get and what are the things you should be focusing on all. So just today, because since we have two sessions today, manufacturing engineering, which is what I'll be talking about. The second session would be taken by our friend Mr. Jitendra Bhambure on quality assurance. So I've got some 20-25 minutes. I'll give a more of a brief outlook about the things and some basic fundamentals about it. I hope you like it, and of course, end of the session you can put on the questions, and maybe if opportunity comes, maybe at some time later I can probably touch upon this subject more in detail. So today I begin with whatever I have today. So I'll just put up my presentation. Is it visible? Because now I can't see myself.
Yes, it's visible. Please go ahead.
Okay. Yeah. So what's manufacturing engineering? I call it art and science of manufacturing. Of course, a lot of people may debate on saying that it's a pure science, it's pure engineering. So how come the art has come into it? So my personal belief is that why I'm saying art, because it's a kind of skill set which not many people would have. There are people who have got the eye to see what is really required. The knack of manufacturing engineering, which is a bit different from hardcore manufacturing. So that's why I say, so a person has to have that eye to look for what is to be done, how it is to be done, and combine with the science and engineering and see how the plant can be run efficiently. So that's why I call it as art and science, because while most of the production people, most of the manufacturing engineering people would be able to run a production unit, but not all the production person would have the knack or aptitude about manufacturing engineering. That's why I call it's a lot of skill involved into it, along with the science. Now, what it brings in agile manufacturing approach, because what I mean by agile is that you should be able to meet the customer demands in a very short time. Whatever may be your setup, if suddenly the demand changes, if the customer requirement changes, we should be able to change our setup and deliver the customer requirement in a very short time. And of course, lean manufacturing, all of you, as you know, that it not only involves the people and also at the cost at what you are able to do. Basically, how lean way you are able to run a manufacturing organization to ensure cost competitiveness and obviously improve. So what it brings, basically, it brings in operational excellence. And when I say operational excellence, what it means? If you are able to run a well-oiled machine, it increases the profit, it reduces inventory, and most importantly, it improves the cash flow. So if your plant is well oiled and it is well running, then these are the benefits that you get. And manufacturing engineering people plays a major role in ensuring that you have a well run oil. I mean, if you have to compare with what I mean is, for example, we have of course, though our national sport is not cricket, but a lot of people talk of cricket. Now, cricket is more of an individual game. I mean, if 2 or 3 people perform on a given day, probably you can win a match. But if you see a soccer team or a football team, it's a team game. But again, there's a difference between that team and what I'm talking about in manufacturing, for a simple reason that in football, though it's a team game, but at the same time, each individual has got a skill within himself. And there's a single coach you have. So the person who's playing at the back has got certain skill. The person who's playing in the forward has got certain skill. And there's a coach who takes care of it. More closer to a manufacturing is what I can think of it is that what you see is in Kerala boat race. Typically, they have this boat race during a certain months of the period, where you'll find that there'll be some 20 odd people. The boat size is something around 120 feet, some 20-30 people rowing the boat. And there are 4 or 5 people who are guiding them. And it is not one day affair. It is not a one day affair. What happens? They coach the people, they train the people, they know whose strength is there, and how he will row the boat, whether he should have a longer shovel or whether he should have shorter shovel. तो वो देखते हैं, उसी हिसाब से 4-5 लोग पूरा चीज प्लान करते हैं, बाकी लोग फॉलो करते हैं. एक और डिफरेंस क्या है कि इन फुटबॉल you are able to see the opponent and accordingly you can change your strategy. Whereas boating row में क्या होता है, you are not able to see the, you have to excel yourself within yourself actually. So that's why you have to have, I'm trying to correlate more with that kind of sport, where you have to have the synergy, you have to have the teamwork, and it has to be well oiled. Now, what is the role of manufacturing engineering team? Design manufacturing processes. Why? So that आपका जो process है वो consistent रहे. Every piece has got repeatability. The process is set in such a way that whatever component you produce, not only produce a quality component, but you have the consistency and the repeatability. Also, they will ensure that they plug the leakages. Leakages are typically, जो मैं last time बोले थे, जैसे कि like scrap हो गया या rejections हो गए, उस तरह के leakage process इस तरह से बनाना है so that the scrap is minimized, the rejections are minimized, and at the same time without compromising on the output. And of course, safety is also they keep into mind, because if the operator knows that his work is very safe and he's not going to harm, then obviously he will be able to give a better output, better productivity. Other thing what they take care of is improve productivity. Of course, I'm using a word throughput. I love to use the word throughput than productivity, and I will explain in next slide why I want to use the word throughput. Productivity, all of you understand, is what the output given by a particular machine or by a particular assembly is what we call productivity per hour or per shift or per month, whatever way you want to capture it. Flexibility, as I said, the setup is such that you have the flexibility. That means the changeover time, setup time इतना कम कर सकते हैं, so that अगर हमको suddenly change करना, because customer demand can change anytime. Suddenly there is a change in the plan. Then we have the flexibility to change over. One. Secondly, do we have the flexibility to manufacture another component in a very short time using the same set of machines? So whether our system has got how much flexibility our system has got. And of course, explore new technology. Like last time I said that technology is also important. Manufacturing, if you are doing it, then how well you are able to do. Whether you are able to reduce the cost of manufacturing that component, whether you are able to improve that quality of the component using new manufacturing technology. And third is most important, that they also work on work instruction and SOP. जैसे कि मैंने बताया that example of rowing boat, where they will clearly define each and every operator in each and every machine उनका क्या काम है, and they are supposed to just follow that. They don't want everybody using their own brain. Of course, there is another system, Kaizen is there, which I'll talk to later. But once it is decided, work instructions are given, standard operating procedures are given. That's what they make, and they have to ensure that the operators follow it. And of course, before that, there are a lot of other work, training, and a lot of other things they have to go through. But this is one of the role of manufacturing engineering. Now all of them. So what are the techniques of making a plant more efficient or more or bringing in the manufacturing excellence? Is to improve throughput. In the previous slide, as I explained, that productivity and throughput, the differences, productivity is good, but productivity is not all. Because when we talk of productivity, we talk of productivity of a machine or of an assembly line or that's how you count the productivity. ये machine ने in 1 hour how many components दिए, या in 1 hour how many components it has machined or fabricated, or what they have done actually. But that's productivity. What throughput I mean is that ultimately the throughput of a manufacturing unit is governed by the lowest productive machine. Assuming that सारे component आपके एक particular machines के through जाते हैं, उस और वो machine का जो productivity, that is the throughput. To explain you, typically suppose you have a team of say 20 people and you've gone for trekking. So you know that from point A to point B you have to reach. Now the full team A से B कितना time लगेगा, that will be determined by the weakest person in your team. There will be some जो जल्दी पहुंच जाएंगे, जो slow पहुंचेंगे, but जो सबसे slow पहुंचेगा, that is actually a throughput. So even if you have certain machines which is more productive, it's not going to help you, because you're not going to gain. It will only create more inventory, WIP, because बना के क्या करोगे? Ultimately जो आपका bottleneck machine है, that is governing a throughput. So that's the difference between productivity and throughput is what I wanted to explain you. So how do you remove those? How do you increase the productivity or the throughput? By debottlenecking those areas which is giving the lowest output. What are the methods? अगर assembly line है, line balancing करके, line balancing के कई तरीके हैं. उसका जो काम है शेयर कर सकते हैं, या उसका जो लोड है को शेयर कर सकते हैं, कोई दूसरे ऑपरेटर को दे सकते हैं कि नहीं दे सकते. सिमिलरली मशीन में कुछ सेटअप टाइम कम करके या बाय गिविंग अ हेल्पर टू हिम वेदर आई कैन इंप्रूव द प्रोडक्टिविटी ऑफ दैट मशीन व्हिच इज माय स्लोएस्ट प्रोड्यूसिंग मशीन. कैपेसिटी बिल्डिंग, वेदर आई कैन बिल्ड सम कैपेसिटी इन एडवांस, इन द सेंस दैट अगर मेरे बाकी प्लांट्स 2 शिफ्ट में चल रहे हैं तो मैं उसको 3 शिफ्ट में चला के उसका एडिशनल बना सकता हूँ कि नहीं, बिकॉज दैट इज माय बॉटलनेक. अगर उसमें से पार्ट्स नहीं निकलेगा, बाकी मशीन कितना भी पार्ट्स प्रोड्यूस करेंगे, कोई मीनिंग नहीं है उसका. टाइम एंड मोशन स्टडी इन द सेंस कि अगेन दैट बॉटलनेक मशीन और बॉटलनेक एरिया और बॉटलनेक लाइन, उसमें कितना टाइम मेरा वेस्ट जा रहा है, मतलब मटेरियल फीड करने में कहीं डिले हो रहा है कि नहीं हो रहा है, या वो ऑपरेटर को कहीं और जाके कंपाउंड लाके फिर मशीन करना है तो उसमें टाइम जा रहा है कि नहीं जा रहा है. वो सब टाइम हम कैसे प्लग कर सकते हैं to increase the throughput. Similarly, ergonomics, the way he's standing, the way he's sitting, whether उसमें fatigue आ रहा है कि नहीं आ रहा है, access to material उठाने के लिए उसको ज्यादा stretch करना पड़ रहा है कि नहीं पड़ रहा है. So those are the things which they will be working on to ensure that the productivity of that machine. Why I'm saying productive of that machine? Because that's a bottleneck machine. वो ही आपका throughput define कर रहा है. I'm repeating that word again and again. Because what happened, a lot of times we say कि हमने productivity बढ़ा दिया, या तो हमने एक रोबोट लगा दिया, या तो हमने वहां पे एक अच्छा मशीन ले लिया जो आउटपुट दे रहा, बट शायद वो मेरा बॉटलनेक मशीन या बॉटलनेक लाइन नहीं है, बट वी हैव एंडेड अप स्पेंडिंग मनी ऑन दैट. लो कॉस्ट ऑटोमेशन, अगेन low cost automation, again to that area where we have the constraint, not anywhere. And of course, low cost, when I say cobot, by using cobot, whether I can increase the output of that particular machine by which the throughput can be increased. Then other things is layout, how well the layout has been defined. Again, the layout jo hona chahiye, again decided by the ME people, because they will study the process, they will study the component that is to be made, they will study the machine that is available with us, and uska layout kaise hona chahiye so that minimum possible space mein, with minimum stress, with minimum of fatigue, we can get a best layout. For that, of course, the base is 5S. All of you know what is 5S. I'm not getting into it. If 5S nahi hai, to fir, you cannot do anything actually, because you'll be struggling to find a component, or there'll be clutter in the shop floor. You might be carrying some unwanted material which you may not be using. The first basic thing, of course, is 5S. So, and the basic principle of layout is whether the whole material movement is, whether it is unidirectional or not, and one touch flow or not. One touch, of course, I have written sometimes one touch may be difficult, but minimum touch means minimum handling करके machine material input से out, मतलब फैक्ट्री के अंदर आने से मिनिमम टच में बाहर हो जाना चाहिए, और यूनिडायरेक्शनल. ऐसा नहीं हो कुछ मेटल एक डायरेक्शन में गया, फिर बाद में हमको मूव करके और कहीं रखना पड़ा, फिर जगह नहीं हुई तो फिर और कहीं रखना पड़ा. सो दीज आर वेस्ट ऑफ टाइम एक्चुअली. सो वन इज फ्लो शुड बी यूनिडायरेक्शनल, सो दैट इट्स फ्लो ऑफ द, सो लेआउट ऑफ द मशीन एंड इक्विपमेंट should be such that the flow is unidirectional. ऐसा नहीं हो कि एक मशीन इधर ऑपरेशन हुआ, फिर जाके पीछे दूसरे मशीन में ऑपरेशन हुआ, फिर जाके तीसरे मशीन और कहीं जाके ऑपरेशन हुआ. It should be a single flow, and as far as possible one touch. एक टच में एक ऑपरेशन होना चाहिए. मुझे वही कंपोनेंट 2-3 बार टच नहीं करना चाहिए. So what are the benefit is optimizes space, obviously, because what happened, your same material is not lying at 2-3 places. Reduce resources, because if you have too much of distance or too much of cross movement, आपको ज्यादा metal handling equipment चाहिए होंगे, जैसे forklift हो गया, या pallet truck हो गया, या battery operator, you will be needing more resources for do that. Improves output of a person, क्योंकि if he is traveling more, या ज्यादा distance travel करना पड़ रहा है, तो उसका fatigue बढ़ता है, उसका time भी जाता है, fatigue भी बढ़ता है. So that also reduces your output. And improve visibility. They also ensure that कैसे उसका visibility रहेगा. Visibility रहने से क्या होगा कि अगर किसी मशीन में इन्वेंट्री ज्यादा बन रही है, WIP ज्यादा बन रही है, you can stop the machine. Sometimes we have a tendency to see कि ये मशीन का प्रोडक्टिविटी है, बनाते जाओ, बट आगे के मशीन में अगर बॉटलनेक को बनाए कुछ फायदा नहीं है. It is only adding to your inventory. So when you have a layout where the visibility is better. You दूर से दिखेगा when you're taking a round on the shop floor, you know कि ये machine अभी बंद करना चाहिए, नहीं तो ये हमारा पैसा रोक के रखा हुआ है, because you're working, it'll impact your working capital. So what are various types of layouts we have? One is job shop. Job shop basically means where you have set of machines where a product goes through a different operation. Then you have functional type where each machines of each type are in one area. For example, press shop alag ho gaya aapka, molding shop alag ho gaya, coil shop alag ho gaya. So functionally they have been divided. And third, of course, cell structure. Typically automobile industries में या component बना रहे हो तो उसमें cluster use करते हैं कि एक ही operator 3-4 machine कैसे handle करे. Because क्या होता है जब machining होती है तो it's not that once he loads the machine takes some time. That time the operator is idle. So that idle time में दूसरी machine सेट करके दूसरा ऑपरेशन कर सकता है कि नहीं, या तीसरा ऑपरेशन कर सकता है नहीं. So depending on the operation, depending on the component that you are making, the layout has to be decided. It could be a job shop, it could be a functional, it could be cluster. Cluster maybe there are 2-3 varieties are there. It should be U-shaped, it should be front to each other, whether manned by 2 people, whether manned by 3 people. So depending on the product that you have, depending on the machine that you have, depending on the operation the machine is doing, the layouts is being set by the manufacturing engineering to optimize the space, give the best productivity, lower the number of manpower required, because manpower another benefit is that machine will not be running idle. Otherwise, if the machines are lying apart and one operator is handling ek kar sakta hai, by the time reaches the operation is over and the machine is lying, but you're lying idle, and your power bill is on actually. So layout plays a important factor in ensuring that your product that you are making is competitive. Then of course the metal handling, they also decide what kind of metal handling facility we should have. Typically whether to transfer the finished goods or whether to transfer component from one machine to the other machine, you have to decide what kind of metal handling. First, of course, is to reduce the gap between the two operations. And certain places probably you won't have the option but to have that gap, or sometimes the material is heavy for movement, or it is at a distance, but how to take it to a distance. Or if you are making a finished good, then how to ensure that the finished goods from end of the assembly line is transferred to the finished goods area. Or if you're working on 2 floors, what kind of metal handling we should have. So they also decide what kind of metal handling is optimal for kind of operation that you have. So these are various types. One is overhead, where you can transfer lighter material across one end, from the one end to the other end, and wherever required you can take down the conveyor and take it up. Then you got the roller conveyor. Roller conveyor can be powerized as well as gravity flow, depending again on what kind of product or component, what is the distance between the two travel, you decide the roller conveyor. Belt conveyor generally for light product or component, or where the chances of damage or scratches would be there, again you use a belt conveyor. Of course, I'm not talking about the conveyor line for making product, but these are conveyor more for metal handling. So again, a manufacturing engineering team decides what kind of conveyor you should have. Some places probably you can go for AGV, auto guided vehicle, where it is programmed and then automatically at a predefined interval, it's a kind of robo vehicle which carries your material and transfer to the desired place where it is to be. A next operation has to be done. So depending again on what kind of volumes you have, what kind of product you can have, you can have any of the metal handling or a combination of these metal handling equipment, with the eye to improve output, with the eye to improve the throughput, and the best option which will be more competitive also. So metal lift, as I said, if you are working on 2 floors, then what kind of metal lift you should have? Should you have a standard metal lift, or should you have continuous lift जहाँ पे the lift continuously ऊपर जाके नीचे आता रहता है, so kind of collapsible type lift होता है, या आपको integrate करना, ऊपर जाने के बाद फिर वो आगे जहाँ पे designated point है वहाँ जाना है, so whether you need an integrated lift. So depending again upon on your layout, on your product that you make, on the component that you make, manufacturing engineering people decide what kind of metal handling equipment one should have. This is again very important, continuous improvement. Whatever I said about it, it has to be continuously worked on. So you should not think that MEI का एक बार काम हो गया, उसे set कर दिया, सब design हो गया तो काम हो गया. It's not necessary that that's the optimum solution. it is important that a continuous improvement you have to, so that team will keep on working on continuous improvement. One, of course, the technology that is coming. Secondly, processes कुछ कम कर सकते कि नहीं, पहले तो process defined हो गया, because they take the design, they take the drawing and set the processes. Over a period of time, they realize that probably certain processes are unnecessary. You don't need to have that process. So whether I can reduce the process, one is the quality improvement, the other is number of processes by which automatically your cost of manufacturing will come down. Gamba Kaizen, if someone is struggling, so they will go at the site and at the place where the operator is working to see why he's struggling. Though we have given an instruction, sometimes what happens, you overlook while making an instruction or SOP, and when actually start working on that, then you realize, no, so something more has to be done, then only it will happen. So, or he's already doing, but there is scope of improvement because you got a Kaizen from someone, and then you say how to apply. So Gamba Kaizen is basically Kaizen study at the site, any improvement process. Mistake proofing. If you find that there's a possibility, the process that the operator can make mistake, what kind of jigs and fixtures should be designed so that he doesn't make any mistake while processing that product or component or doing that assembly? Because obviously if you make some mistake, either you reject it or you rework it. So how to make it first time right? So they will design a fixture and jig according to that, so that you do not lose your productivity, you do not lose, do not scrap any component, or you do not have to reject any piece of it. And of course, updating the process sheets. And of course, updating the process sheets. Just 1 minute. So as and when the process improvement happens, you have to ensure that these are updated in the process sheet, because it shouldn't happen that process sheet say something and you updated and you updated, improved the process, but the process sheet is not updated. And of course, the Kaizen awards, you have to come out with Kaizen awards. And basically, this is to motivate the operators. This is basically to motivate the operators. You can motivate the operators by giving them awards, which can be used. But the key is that even if the Kaizen is given by the operators or by the engineers, they should not implement immediately. It has to pass through the manufacturing engineering team, because they will decide whether that it's really workable or not workable. One. Secondly, if the Kaizen is coming from an area where we already have excess being produced, actually it's not much of use. The Kaizen should come from area where you actually have a bottleneck, or you are having some quality issues or some process issues. So though awards can be given, or some kind of token awards can be, appreciation can be given for awards, but the implementation should be vetted by the manufacturing engineering team. So how does it help? Of course, everything helps in reducing the manufacturing cost. So reduce the process time. The team works on to see how we can reduce the process time. So you save on your operator's time, you save on power bill if you are able to reduce the processing time. Reduce the number of steps in the process. As I explained, that if you are doing a current product on, say, 5 steps or 5 different processes, can it be done in the four steps? Certain process probably may not be really necessary, or whether I can improve upon it, which will again reduce your manufacturing cost. Reduce rejection and scrap. If your process well defined, it is well controlled, it's definitely reduce your rejection and scrap. And more important, the changeover setup reduction. As I explained, that they will work to have flexibility. How can I keep my machine running up? Because you cannot have a long production run, because if you take a long production run, you will end up having inventory. So better to have a short production run. But when you have short production run, what happens? A lot of time goes in setting up for the new product or new component. How can I reduce the changeover time, so that in 1 minute, sometimes 1 minute may not be possible, but idea is that how I can make the setup change in a shortest possible time, so that my machine uptime is more and I can run a shorter production run. And of course, reduce WIP. If you are able to run shorter production run, then you are able to reduce WIP, because you produce and then you move to the next station. So between the 2 machine or 2 stations, there is no inventory. It is a continuous process, and you are able to change the batch size according to the customer requirement, by which you can reduce your WIP. Reduce the lead time. How it reduces the lead time? Because if you have got 4 customers, that means you have to make 4 different varieties. But if you take a long run, obviously the 3rd or 4th customer has to wait till your production run has not got over. But if you are able to reduce the production run, you will be able to satisfy more customers, and can reduce the lead time of delivery of that product or component. And obviously it will reduce the capex, because if you are able to implement all those things, productivity improvement and throughput improvement, probably you can still achieve a higher bottom line by reducing, by having a same set of machine, or by having a lower capex. Other thing, what people do, if you have a more complex factory or more complex manufacturing, there are various ways by which you can monitor. Because one is that, okay, what is happening, but how on a real time basis, how to ensure that you are able to, you are in control of what you are planning to do. So their unknown systems are there, where visibility, if certain area gets stuck or certain support is required, so that people can get into it and help the operator to ensure that the line is running or machines running, or where suddenly the rejections have increased, then how immediately support can go. We need not wait for the end of the day, the report comes next day, and then realize that so much of loss has happened, and then we take action. So now you can definitely have this electronic system by which you can have the what you call 4.0, like unknown system. You can have, then you can have human machine interface, and of course you can have the process sheet also display on the, so that operator can, what happens if a particular location or station, if an operator has to do 5-6 components, it's very difficult to put 5-6 process sheets. So you have digital process, and he selects that screen or that process which he is going to process. So so it will store all the processes, and he can download and ensure that whatever he understands goes through the SOP, and ensure that he produces component as per the as designed by the manufacturing engineering people. So you can have a control on quality, energy, and productivity on a real-time basis. You can intervene immediately if you find suddenly in the graph that suddenly the quality has come down, or a machine is consuming more energy, or the productivity has come down, so that immediately the manufacturing engineering team can go there, immediately try and understand what the issues are, resolve the issues in a very quick time, and are able to ensure that the uptime of the machine is increased. So there's another thing, but of course this would be required more if you have a more complex process, and if you have if you want to monitor from a remote area, then of course you can have this setup. A bit of expensive, but definitely there's a payback for having this kind of facility. So this is just a depiction of it, that basically what kind of unknown system you have. You can have the signaling system where red means there's some problem is there, or orange means they assume there's some problem is there, otherwise green means it is running properly. You can have a big board on the shop floor, where on a real-time basis you know which station is producing what, whether they are producing as per the targeted plan or not. So these are the indications. If it is as per plan, it will be green. If it is slightly behind, it will be red. So you can all sorts of system in the industry 4.0. But of course, these are advanced system. If you feel that you have enough of scope for this kind of thing, if your operation is more complex, you can definitely have this kind of system. I'm not getting into, because of the limitations that we have. I'm not going into detail. Whatever I explained, there is a methodical way of going towards. There are different phases of how you go about mapping all the processes, and not only the processes, the whole factory. What kind of capex is required, what kind of layout it should be, what kind of equipments are required, where should be placed, what is the sequence of process, training of the operator, training of the engineers. Everything is being taken care by the manufacturing engineering department. So phase 1 is basically manufacturing strategy. We should be clear that what we will make in-house, what we will buy from outside. According to that, what kind of equipment is required, what kind of tool fixture, what kind of machines would be required. Phase 2 is designing of manufacturing design assembly, means how the thing would be designed, whether it's a assembly line is to be designed, or machine has to be put. So complete study has to be done, layout has to be planned. In the first, it has to be done virtually. So, and a simulation you can do so that you don't go wrong. Today, a lot of software is available where even before setting up the layout, or even before buying the machine, you can do a simulation, and you can see whether your layout and your selection of machine equipments are optimum or not. And then you design the manufacturing process. As I told you, the process flow, the sequence, the jigs and fixture that you design, training of the operator. You will do the analysis, control plan, what kind of metal handling system you should have, PFMEA you should do if required. So that is in the third phase. Fourth phase is more of a validation, where the manufacturing people themselves will be available, standing on the shop floor and running the pilot batch to ensure that whatever they have thought of it, whatever they put on the SOP or work instruction, whether really working or not, to ensure, and whether the training giving to the operators are they have understood or not. So pilot run will be done in the presence of the manufacturing engineering people, and finally, of course, it will be transferred to the production people. After ensuring that now nothing can go wrong. I mean, it actually foolproof process. The process are controlled. The manufacturing the machines are right. The productivity is right. The throughput is right. Layout is right. After ensuring all of that, then it will be transferred to the manufacturing people for the mass production. So there are a lot of techniques are there. I'm not getting into details. There are ways to do it. There are different ways to do it. Work out what is right for in a running factory. Again, there are ways how to figure out where the bottleneck is, where you're losing money. So there are techniques. There are methods to do it, and it's so depending on where you are and what you want to do, it depends on that actually. So today I'm leaving at this as a more of a food for thought, but I can definitely take questions now or later. Anyone, if you have any questions, I can talk about it. It's a very interesting subject, but the key lies here, that how well you have designed your shop floor, the machine manufacturing and thing, which will govern. So this is the difference. This will be a differentiating factor, and which will definitely help you in improving your bottom line. So that's it for the day for me from my side today.
Thanks, Mr. Roy.
I can take the questions later and after the end of the second session, I guess.
Yeah, there was one question which actually did come up, but I guess that question came just before your Industry 4.0 slide came up.
Doesn't matter.
So it was Mr. Vasu who said that world is moving towards Industry 4.0. Digitization is today's buzzword. Please define what level of digitization should I do in manufacturing? I'm sure he's talking from an MSME perspective.
Yes, as I told you, it depends on how complex your operation is, because of course there's an investment involved into it. So you have to definitely see what is the ROI for it actually. So there's no limit. You can have a simple system also where you have more of a manual or visual control, whether you want to have real-time basis, remote from remote location you want to monitor. So all depends how much money or how much capex you can invest on that actually, because today everything is available. In fact, now machines are available which has got those interface actually. Earlier machines would not have that interface, though of course you can always put the interface on the built on the machine and capture the data from there. So all depends on how much you can can invest depending on your operation and your profitability actually.
Awesome. Thank you, Mr. Roy. Thank you very much. We will come back after the second session with Mr. Bhambure. He's going to take up on the quality system. So we'll come back again and we will take a few more questions then.
Sure.
All right.
Sure.
So we're coming back to the second session in just 2 minutes, and we'll start this session.
What's the most natural way to look beautiful? Just get 8 hours of perfect sleep. And what's the secret to perfect sleep? My Cruise VarioCool air conditioner. Its VarioCool inverter technology ensures there's no stickiness at night, while the Air Pro filters improve the air quality around you, creating the perfect conditions for deep sleep. With the new Cruise air conditioner, go get that beauty sleep. Cruise. Invest in yourself.
Awesome. Welcome back. Welcome, Mr. Bhambure. Thank you so much for joining us today.
How are you?
Absolutely good. Thank you so much for joining us back again. And we are looking forward to your session on quality systems. To all our viewers who haven't attended Mr. Bhambure, earlier sessions, please do visit our website, rataindia.com. Under the event section, you will get all the events of the Business Masterclass. Mr. Bhambure has over the last 4 decades held various leadership positions in the HVAC&R and appliance industry. During this period, his work gained special recognition in the areas of R&D, product development, cost optimization, vendor development, supply chain, manufacturing engineering, ERP implementation, international OEM development, enabling organizations to achieve measurable top and bottom line growth. His areas of expertise include product strategy and management, technology strategy, setting R&D center, product development, quality and manufacturing engineering, productivity enhancement, value analysis and engineering, cost reduction, vendor development, change management, leadership development, international business development. Mr. Bhambure is appointed as India representative under the Technology and Economic Assessment Panel and Refrigerants Technology Options Committee at UNEP. The group is team of international experts who prepare report for Ozone Secretariat under UNEP. He also actively holds executive leadership positions at industry forums such as RAMA and ISHRE, and has worked with central government regulators as a representative of the industry. Mr. Bhambure is an engineering graduate and has a diploma in management from Mumbai University. He has also undergone executive training programs at the US-based manufacturing plant at Tel Aviv University, London Business School. He's also been with, at the Tel Aviv University, the London Business School, and IIM Ahmedabad, and has traveled across the globe as part of his work. So, to that detailed, awesome profile of yours, Mr. Bhambure, over to you. Looking forward to hearing from you all about the quality systems.
So, Ajit, thank you very much, and thanks for giving this opportunity to share whatever we have learned in a long career, what we have. We believe that we should, pass on this knowledge to others, and that is where our country will, gain, or the MSMEs and the country as a whole will. So this is in a small attempt what we should do. So I'll be requesting you, Ajit, to go to the slide. So if you can please go to the next slide. What is the objective of quality? The quality objective is most important, to build brand and to control cost. And build brand is something, like हमें तो पता है कि कोई countries के brand है based on quality. We always say German engineering quality. We always say Japanese quality. It also means that some countries don't have the required quality, and these countries have built the brand because the whole set of manufacturing, the whole set of approach towards selling, including the trading, they build the brand. And of course, the other part is control cost. And how we control cost, it will come in different regions. So for आपकी खुद की कंपनी के लिए, we'll have to see and look at what is your philosophy. आप प्रीमियम प्रोडक्ट से की फिलॉसफी आपकी प्रोडक्ट में और सर्विसेज में और ट्रेडिंग सर्विसेज से आई एम टॉकिंग ऑफ ट्रेडिंग, और आपका प्रोडक्ट है वैल्यू फॉर मनी, आपका जैसा रिलायबिलिटी. अभी हमें एयर कंडीशनिंग पता है कि फिजित्सु हो जनरल का, दे ऑलवेज टॉक ऑफ रिलायबिलिटी, दे ऑलवेज टॉक ऑफ ड्यूरेबिलिटी. एंड समथिंग वेरी इंपॉर्टेंट, इट इज सेफ्टी इज समथिंग जिसका ऊपर अभी कस्टमर्स, it is non-negotiable. It has to be there. So these are the objectives on which we build. And we should know that building a brand takes a long time. It is not like an introduction of product. It takes time, it takes money. But to destroy a brand, the most important aspect of, or contributor, I would say, is, or in a negative sense, is a bad quality. If the quality is not good at all, the brand can get destroyed in a very short time of 6 months to a year, where we have taken maybe decades to build the brand. So can we move to the next slide? Ajit, you able to hear me? Yes. So now build culture. It's the important, because quality has to be built in the system. हमें पता है, जैसा मैं भी in 1979 मैंने ज्वाइन किया था, तभी तो बात चल रही थी कि प्रोडक्शन और सेल बढ़ गया तो क्वालिटी डाउन हो गई. वो क्या है कि प्रोडक्शन, सेल और क्वालिटी अलग अलग डायरेक्शन में देखते थे और सोचते भी थे लोग, which should not be. Actually what should happen is the quality and production should go together. And हमें it is time and again proven that आपकी सिस्टम में क्वालिटी होगी तो प्रोडक्शन ऑटोमेटिकली बढ़ जाता है. We'll see in the subsequent slides how it happens. Now, most important in building, sorry, earlier slide. Ajit, earlier slide. So most important in how do you build culture is quality should drive the behavior of people at all level, be it sales, be it production, be it procurement, be it the maintenance team, be it the earlier session, manufacturing engineering, and the quality department itself. All put together, that should drive the behavior of all your employees. If they feel that quality is important, and it is not only the production that is important, it is not only because abhi time nahi hai, abhi jaldi se supplies deni hai, there's a pressure from the customer, then production gets say like a higher attention and not the quality, then it is not going to build a culture in your organization. Next slide, please. So how do we build quality? So first and foremost, understand the requirements of customer, because customer is going to define your quality of your product. Even if you are an OEM, even if you are a trader, and if you are trading in a certain components or certain finished products, the customer is going to define. And what are generally customers looking at? Customers looking at performance backed up by certification. Customer definitely look at reliability. Customer definitely look at safety, durability, brand, and value for money. So many of us, in our day-to-day life, how do we define quality? Take of this brand. If you go to TV industry, if you go to any car or any product that we buy, generally हम लोग सोचते हैं कि ये brand का product अच्छा है. So अच्छा in the sense what? It is a quality if that is there. And many a times, value for money also means quality. That doesn't mean generally. ऐसा नहीं है कि सस्ते में कोई बेचता है तो उसकी क्वालिटी खराब है. Generally, it will have lower level of features. Generally, it will have value for money. Air conditioner में देख लोगे तो 5-star and 3-star, or 3-star and 1-star, or additional features, additional looks. ये value for money के items हो सकते हैं, लेकिन उसकी ड्यूरेबिलिटी, उसकी सेफ्टी, उसकी रिलायबिलिटी ये नहीं हो सकते. सो दीज आर द कस्टमर. नाउ वी हैव टू ट्रांसफर दिस कस्टमर रिक्वायरमेंट्स इनटू manufacturing of a manufacturer. So how do we do that? We must look into details of the design validation. Believe me, और डिजाइन में कुछ गड़बड़ हो गई ना तो क्वालिटी कभी नहीं आएगी. Like we saw in cost also, कि design defines about 70% of the cost. Here also quality is defined by the design. Design में समझो issues हो गए तो definitely we are going to get into trouble. Define performance standard, what you want to do. And performance standard usually will be defined at a national level or certain regulatory levels or some international levels. जैसे ASHRAE के standards रहते हैं, जैसे बाकी रहते हैं, उसके standards डिफाइन गए. But reliability standard is something not readily available. And reliability standards, you will have to develop your own. And then most important again is selection of vendors. आपके vendors base अच्छा नहीं होगा तो you'll time and again there will be an inconsistency in quality, or you'll always be getting worried about what my finished products is going to come. I'm not talking only of the finished products as a product, but it can also happen in components. आपका raw material supply ठीक नहीं होगा तो आपके walls ठीक नहीं होंगे. आपके even if you're doing some sheet metal work or say fans for say in a HVAC industry, आपके raw material के vendors ठीक नहीं होगा तो it is definitely going to impact your finished product. And of course, what we said, process control is extremely important. Process which is defined by the manufacturing engineering, वो चल रहा है कि नहीं ठीक से, उसका that is to be seen. And delivered quality. Your product when manufactured is good, but how it gets transported, what is the packing, how it gets delivered, that also makes a huge difference. Product आपका इधर ठीक है, लेकिन when it is getting delivered, समझो उसका ऊपर scratches आ गए, उसके ऊपर समझो कुछ dents आ गए, तो फिर भी आपके कस्टमर सोचेंगे कि ये ऐसा क्यों है. जनरली हमें तो पता है कि when we go in market हम बोलते हैं खोल के दिखाओ, because we are not sure of it. But समझो आप imported कोई goods लेते हैं, specifically I am saying from Japan, हम खोल के देखने के लिए इतनी कोशिश नहीं करते, because we are sure कि उसकी delivered quality ठीक है. Next slide please. So we had a session of supply chain also earlier, and we have to build quality across the supply chain. ऐसा नहीं है कि मैं मेरी खुद की quality देखूंगा in manufacturing and मुझे फिर it all will meet the purpose of delivered quality to the customer or building the brand. नहीं होगा. Vendors will play a big role because vendors are giving you raw material, vendors are giving you sub-assemblies, and vendors are giving you components. You're not doing everything in-house. Engineering industry is not a process industry कि raw materials में लाया और finished products बना दिया. So one side there is vendors, other side there is customer. Customers में क्या होता है? Distributors रहते हैं और end customers रहते हैं. अभी in large product manufacturing, आप डायरेक्ट एंड कस्टमर को नहीं बेचते होगे. यू विल बी सेलिंग इट थ्रू अ डिस्ट्रीब्यूटर. और डिस्ट्रीब्यूटर कैसा सोचता है? उसके इज योर प्रोडक्ट से पैकिंग रेडी टू हैंडल मल्टीपल शिपमेंट्स? समझो आपके फैक्ट्री से डिस्ट्रीब्यूटर के गोडाउन में जाएगा, लेकिन गोडाउन से कस्टमर को जाएगा, कस्टमर से उसके घर में जाएगा, और देयर कैन बी सो डिस्ट्रीब्यूटर को भी कैसा समझ पैकिंग क्वालिटी कैसी आता है, इट बिकम्स इंपॉर्टेंट. एंड ऑफ कोर्स द सेंटर पोर्शन इज मैन्युफैक्चरिंग, व्हिच इज फ्रैंकली more and more like defined by manufacturing engineering. Next slide please. So after looking at this complete supply chain, how the quality function should be structured. So it has to be, we have to have something focused at the vendor, something at the process, and something at the customer. And in this, each of these function will require a different approach. Each of these function will require a person who is able to look in a different way. And if that person is not fully trained, then he will not be sensitive to what is to be seen. More so, say process and vendor can be to an extent overlapping. लेकिन customer की जो quality जो देखता है, उससे तो customer की requirements क्या है वो fully समझ में आनी चाहिए. He should not say that according to मेरे process से, मेरे machine से वो ठीक होके आ गया. A customer is not bothered in which machine you are using, whether you are using a robot, whether you are using a standard machine. He wants a product which is of a good quality. He is not also bothered what systems you have got. He is also not bothered of what people who are behind that. He says R&D hai, quality hai, manufacturing hai. He is not bothered about that. He wants only a good product. That's why customer की जब quality देखते हैं, वो that person or that department or that function has to look into a completely in a different approach. So that's why you need to structure it properly. Next slide, please. So after understanding all these things, what is the role of quality? जनरली ऐसा होता है कि जब भी कुछ रिजेक्शन आ जाता है तो प्रोडक्शन का आदमी सोचता है और मेनी स्टेटमेंट्स आर मेड इन लार्जर कंपनीज आल्सो कि क्वालिटी क्या कर रही थी. क्वालिटी इज नॉट अ पोलिसिंग वर्क. बिल्डिंग क्वालिटी इन अ प्रोडक्ट इज नॉट अ पोलिसिंग वर्क कि वो पकड़ ले, वो रुका दे. So what is really required to be done? So quality department should first and foremost create a system, and they should create standards for all what they are going to do, so that everybody in the complete supply chain understand again what he has to be done. They should not be verbal. They should not be मैंने ऐसा सोच लिया था, मैं ऐसा समझ गया था. नहीं तो आपके वेंडर के पास में समझो कुछ चेंजेस हो गए, उनके इधर के एम्प्लॉय चेंज हुए, उनके वर्कर्स चेंज हो गए, फिर भी उनको क्या स्टैंडर्ड से बनाया समझना चाहिए. एंड ISO 9000 becomes really a basic thing. ISO 9000 has lost its shine, I would say, because it is considered more as a ritual. But frankly, if you ask me, ISO 9000 is a basic beyond which we have to. It is something like a minimum that is required. Usually, हमको लगता है कि ISO 9000 लिया तो maximum we achieve, but no, it is not like that. ISO 9000 is something based on which we have to build, and then they have to create a physical infrastructure of implementing the standard, of implementing how they will check it, and build competency in their team. Whether it is 1 person, 2 person, 3 person, or people working in quality system, their competency should constantly be built. The next, once this system has been created, we should get into the audits, because that is the way they are going to do it. Because quality will always be built by or built in the system by the production people, by the procurement people, by the design people. What quality department or quality assurance department can do is they can only monitor. They can check from time to time whether things are in control or not. So what they should do, they should audit, monitor vendor performance, in-house manufacturing process, whether they are adhering to the standards or not, or they are going. And most important, from time to time, get market feedback. Don't wait for a complaint to come back. If they are able to get a constant feedback, look at the trends, look at what is happening, speak to your distributors, speak to the salespeople, and then they will start getting initial hints of what is happening. So market feedback becomes extremely important for timely action. And the last and the most important is constantly improve. So we have when we audit and we find something, we can get market where we find something, we need to redefine the standards and take, more importantly, is the improvement projects. And there are tools available for that. The most common tools are FMEA. Sorry for that error there. It is FMEA and Six Sigma. And build quality walls. More and more quality walls you should build. The next slide will tell you what is the quality wall, what you have to build. Next slide, please. So how do we build quality walls? We have seen across the supply chain, vendor, manufacturing, and customers. So what is important? What is the quality issues that will come within the four walls of your manufacturing? It is better to control there and there itself. The same principles applies to a vendor. So what we should do? You should, how do we build quality walls? So select vendors who have got some basic and fundamental process in place. Check whether they have got ISO 9000 or not. Have a audit process set for them. Sign warranty clauses with them. And one more important is RRT. So what is RRT? RRT is routine reliability test. Usually when a sample is given and it is approved, not necessarily it will remain like that over a period of time. And so define your frequencies and pick up samples and put it for a repeat reliability test. Now these reliability tests may not be very like the first samples you are approving, but they should be fast enough to give a decision whether everything is okay or not. Similarly, in the manufacturing, do design verification from time, first and foremost important. Do process audit from time to time. Do customer inspection in the factory. That means what will customer look forward for? Pick up the machines from the assembly line, open them. Or cross-check them for the design verification performance, or subject them to some transportation conditions. Open them and see whether everything is okay or not. And LRT is long reliability test of the product itself. So keep some products, if you have got running, say for 8 days period, for 15 days period, and see what feedback you are getting and whether it is matching from the first product which was designed and approved. At customers end, most important is field trial, because many things what we know we are done within our four walls not necessarily work through. So when the first design verification is done, do a parallel field trial. Many things will come up because unintentional use, overload conditions, abnormal conditions will only come through field trial, and develop a very strong feedback loop. So these are the walls. If you build, why walls are required? First and foremost, nothing should get passed on to the marketplace which has got issues, and we should try and control from time to time so that the quality system looks and takes care of whether everything is in order or not. Next slide, please. So now this is cost of poor quality. Cost of poor quality, as we move from vendor to manufacturing to customer, it goes, and it becomes exponential. So if the quality of vendor is not good, what will happen? There will be a production loss. You will have to get into a rework within your manufacturing. It can be a warranty issues with the customers or in the market. There can be callbacks because of if you say using a defective motor, you will have to call back your product from the customer, and a loss of sale. If there is a bigger problem, there can be a loss of sale. So vendor can contribute to a large extent in building your quality. And on the negative side, if there are issues in this, then the cost of poor quality become very high. In manufacturing, it can be a rework. If you have to scrap certain items, then it can end up in higher material costs, and of course the production loss. If both because of the vendor as well as within your premises, if certain functions or certain departments have produced a poor quality component, say a heat exchanger, and if you find it in assembly line, that customer's place, the cost goes up high. We know that if I had to change a screw within the factory, it is very easy. If I had to change a motor within my premise, it is very easy. Changing a motor or a screw or a wall, when it goes to a customer's place, it is extremely, extremely costly, and it creates a very poor image. So warranties can go up. If it is a callback, it is a huge, huge cost. It can end up in a loss of sale, because if your distributor can say, I don't want to touch your product at this stage till everything is in order. And the most important thing is rebuilding the brand. The cost is extremely high of rebuilding the brand. So outside manufacturing is the design. If the design is not validated, it is a potential disaster in the field. If a product design is not good, sure, it is going to create problems in the market. Next slide, please. Now, where things can go wrong. In a steady state condition, we can say everything is fine, we have worked, we are stabilized, we are auditing, everything is okay. But it is not so. Areas we should watch is engineering changes. We do small engineering changes for improvement. We do engineering changes as a customer feedback. And then we introduce new vendors from time to time because he'll be cheaper, or the existing vendor is not able to give the sufficient supplies, or as a strategy you want to have two vendors. Cost reduction projects. These are the most dangerous, because somebody will come and say that I can save so much of cost per annum, and then we get driven by that, and we don't look at what are the implications. Then product launches. Whenever you are doing a new product launch, or the first time when you're developing a new product, it can get into potential issues. Process changes. If you don't validate the processes, then it can become a potential thing to create poor quality. And of course, packing, which we are discussing the thing. So we should not give production in terms of these areas and an overriding situation over quality. That is the most important message which we should, that is the most important thing which we should look for. Next slide, please. Now, you require a governance. And how do we look at governance? So we have said we'll develop strong processes, and we'll also do auditing, or we can say earlier slide, please. So we'll do a strong monitoring process, auditing process, but we should also look at people. If we don't have people's participation in the whole thing, and if you go on making stronger processes or more and more processes and more monitoring and audit, it will still not give you the required quality, because people's involvement, change in culture, building the culture is the most important thing in the governance system. Usually people get to an extent a secondary role in the whole system of building quality. Next slide, please. So consistent quality will create a premium image, reduce cost, and improve margins. This is my final slide, and we should constantly work towards it. So thanks, and I had to rush. I had planned to give some detailed examples, but because we are doing 2 sessions, I can understand. I didn't want it to cross the time, but still we are crossed by about 5 minutes or so of a 1 hour session. So back to you, Ajit.
Awesome. Thank you so much, Mr. Bhambure. Before we get in a few questions quickly, I want to actually bring in Mr. Roy, and we also have Mr. Deepak Thakkar who's with us. Welcome, Mr. Thakkar. Thank you so much for joining us.
Hi, good evening.
Okay, so Mr. Thakkar, I'm going to ask you the first question to get this, just warm up this Q&A session. Quality is usually associated with manufacturing. What is its role in trading? I mean,
yeah, thanks, Ajit. In my mind, quality is not just limited to manufacturing or trading even. Quality is extended to sales, is to finance, is to HR. I mean, the quality culture has to come into each and every function in a business environment. But but going forward, I'll limit my answer to its role in trading. Now there can be many situations or many type of organization which are a member of RATA. Let's say if it's a pure trading organization representing a large company, Indian brand or a multinational brand, that can be one situation. The second is there is a manufacturer who's not only manufacturing but also importing and selling some products from India, or representing an Indian company. That can be a second situation. So let's talk of both the situations. I mean, how sensitive it is and what kind of thing one organization should do to make sure its quality is good that is going to the customer. So I think the easiest is when it's still like a pure trading company which is representing a large brand, Indian or a multinational brand. I think the sensitivities are less because that large brand itself is very concerned about the quality it goes, its quality that is going to the end customer. Okay, so that's a little less sensitive from that perspective. But when a trader, a pure trader or a manufacturer is representing a foreign brand or an Indian brand, which is a medium MSME, then the role of quality or quality checks become very important. And because it's basically that company which is in front of the customer. So it can potentially rupture its brand, or it can impact its cost, or it can impact its business. Now, for a company which is actually has got one leg into manufacturing, there it is a little simpler riddle, because that company already has some processes for its incoming raw materials. So there is no need to replicate a separate system for a trading product. So whatever system it has for incoming raw material, it can use the same for incoming trading products into its warehouse or factory. And likewise, it has a finished good quality system when it is going out of the factory. Same quality system should be deployed for trading products also. And in addition, it's very important to periodically visit that factory and see, whatever it is, the statement it is making, actually it is falling in letter and spirit in its factory or not, in terms of the quality system, in terms of processes. So my sense is quality is actually very important for trading products also. Yeah. Thank you.
Awesome. Thank you, Deepak. Mr. Roy, an important question that's come is, how cost accountant can play a role in manufacturing engineering? How does a cost accountant work around this?
Yeah, so as I explained, the whole activity ultimately, end of the day, is to increase the bottom line. As I mentioned in my talk also, that increase the profit, reduce inventory, and improve the cash flow. Now, how do you get a feedback? I mean, whatever actions you are taking or whatever improvements you are doing in the shop floor, whether it's really translating into improving the bottom line. So that's one of the reasons that cost accountant has to play hand to hand with the manufacturing engineer, number one. Number two, if he has to get the detail of how much that the workstation or that assembly line is costing me in terms of depreciation, in terms of interest, in terms of wage, in terms of electricity, all those information is required by the ME guy from the cost accountant, so that he knows that which is, of course, he would know which is the bottleneck area, because from the inventory, from the output, or from the WIP, he can make out which is the bottleneck area. But how much is the inventory in the system, and how much a component that is being produced from that machine or that assembly line, what is the cost of producing? Those information on a regular basis would be required by the manufacturing engineering to validate what actions they are taking, really getting translated into making money. Ultimately, end of the day, what is the goal? Business, the goal is to make money, actually. So it's very important that both of them have to play hand to hand. At the same time, cost accountant alone, if do not have the manufacturing cost alone cannot do anything, because he can only capture the data. This is what happens. Sometimes those data may not be realistic, because he will do from the whatever has been, what you call, mapped in the system. Sometimes the mapping on the system may be bit old, or may not be mapped properly. Typically, the hours taken by for manufacturing that component, whereas reality could be different. So both would go hand to hand to check what is reality and what are the areas of improvement, and whether those improvements indeed are helping in bringing or improving the bottom line on.
Awesome. Thank you, Mr. Roy. Mr. Bhambure, one question for you is, how do we migrate from inspection to quality assurance? How does that happen?
So the older system was inspecting, which means that somebody is producing, somebody is checking and saying yes or no. So it is more like a policing activity. Quality assurance is something that is built in the system, and built in the design, built in the vendor, built in the process, and the entire organization works towards the quality becomes not a separate part, but an integral part of each and everything. What will happen because of this? It will means that the rejections will be very, very less. The issues will be known very well. A practical case, if you take, if a finished good or a component lands up in your incoming inspection, and you find it is of no use, there will be discussions that will be happening between procurement department, between quality department, and within the vendor, that whether it is what it is, how it is. Or take a case like a finished good, say at the end of the assembly line, we find that it is not okay as per the standards, as per the inspection process. Then what will you do with it? The entrepreneur or the owner or the production head will be in two dilemmas. One is looking at quality which is not good as told by inspection, and the other side, it can become a potentially huge loss. So quality assurance, or migrating to quality assurance, will ensure that the quality is delivered to the end customer, and there is a foolproofness in the system that nothing will go wrong. I would say 99.9%.
Awesome. I guess we just have about enough time. We've just crossed our time for this. So to all our viewers, first of all you three gentlemen, thank you so much for being part of this masterclass. It's almost 1.5 months since we've been doing this, and time's just flown by. And it's been a great learning journey for the entire manufacturing members of us, including non-manufacturing members. Next Friday is the last session. So you have one more week to go through if you have missed all those earlier sessions. And everyone's going to be back here next Friday at 6:30 to talk about the last session. Mr. Tucker, you're going to talk about an interesting topic, which is all about going to market and including exports. So that should be interesting. But Mr. Bhambure and Mr. Roy also will join us. So if you have any questions from the previous sessions, they will be available to answer these questions. So thank you very much. Thank you very much for being here, and look forward to the next final session of this entire 6-part series next Friday at 6:30 p.m. Thank you very much.
Thank you so much.
Thank you.
Thanks, Ajit. Yeah.